Hi and welcome back. In this video we're talking about generator classes and iterators. Here I'm going to show you a class which implements the 100 number generator we did in the last video. So I'm going to call it first 100 generator, like so. And then we're going to define an init method, which is just going to start the number off as 0. And then we're going to define a next __next method. When you define a next method in a class, any object you can then call next of my object, like so. So this is again a dunder method that allows you to call next on it. It also tells Python something pretty important. We're going to look at that in just a moment. So if we wanted to generate 100 numbers, all that we have to do is get self.number, return it, and increment it by 1. So, if self.number is less than 100, we're not going to use the yield keyword here, by the way, because you don't need to in a class generator. In one of these things. I'm just going to not say anything that could potentially be misconstrued as wrong, just so I don't confuse you. What to do is, if the number is less than 100, we put that in a variable, then we increment the number by 1, and then we return the current number, which was the previous value. So that's 0, we increment self.number by 1, we return 0. Okay. Now, important, on a class, we have to, if we want to stop returning numbers like so, we're not using a loop here to stop us when we reach 100. So when we reach 100, we have to raise a special error which is called stop iteration. Stop iteration error tells Python that we've reached the end of this generator. I'm saying generator, I'm flinching slightly here. Because this is essentially a generator in that you start at 0, then you decide whether you want to return a new number. You get that number and then you return it, and then the program stops. But your object remains and it remembers self.number. So if we have my gen, and that's a first 100 generator there, my gen.number is of course 0 at the start, right? Let's show you that. My gen.number is 0 at the start. If you do my gen.next, like so, and then print my gen.number again, you get 1. That makes sense, right? Because the next method here is checking if the number is less than 100, then incrementing it by 1. So this all makes sense. Now, in order to make it behave like a generator, we just say next of my gen, like so. Then we can run this again, and the same thing comes out. Of course, next of my gen is actually returning the number that it had before we incremented it. So instead of printing my gen.number here, we can just print next of my gen, and here we can also print next of my gen, and we'll get the same output 0 and 1. The first time we call next, we get the current value, which is 0, but we've incremented self.number by 1. The next time we call next, we again increment self.number by 1, but we return the previous value, which is 1. So now this is behaving exactly like a generator, and indeed, this is a generator. It's not storing all of the values up to 100 in a list. It's giving you them one by one. It's generating them as you call the next function. Sorry, the next method. By the way, dunder next is new in Python 3, so if you're using Python 2, you'll have to define next without the underscores. Okay, that's only for Python 2. If you're using Python 3, use dunder next. Okay. All objects that have this dunder next method are called iterators. All generators, like this one, are iterators, but not the other way around. So you can have iterators that don't generate numbers. For example, if you modify your first number generator to return part of a list, like first 100 iterator, not generator, you can have an init method here that says self.numbers is 1, 2, 3, 4, 5. Obviously, it's not first 100. Let's say first 5 iterator. Self I is 0. So that's the index at which we're going to start returning, 0, and the numbers that we're returning are from 1 to 5. And then again, the next method here is just going to say if I is less than len of self.numbers, return self.numbers I. Right? Else raise stop iteration. Sorry, you can't see that well, but there we go. So all we're doing here is we're not generating anything. We're saying if I is less than, and by the way, we have to, of course, we have to do this. I plus equal 1, and return current. We have to increment 1. We have to increment I by 1, of course. Again, we're not generating new numbers. We're keeping track of I, the index we're currently at. You have to do that somehow in order for, this should be self.I, by the way. You can tell that I've not actually prepared this example, but I just wanted to show you quickly that not all iterators have to be generators. In this case, you're not generating the numbers, you're returning them from a list. So, just a quick example there. You'll have this in the sample code for this section, if I can remember to add it in. So, that here, what we do when we define the next method is we define an iterator, something that you can go over one by one by calling the next function. It doesn't necessarily have to generate all its numbers, but it can. But again, it can also return them from a list or from a set or anywhere else. So, in Python, it's important. Iterators are those objects that have a dunder next method. You can call next on them. We have ourselves an iterator, but we cannot do for I in mygen. You cannot do this, let me tell you that right now. If we run this, you get an error that says first 100 generator object is not iterable. I just said it's an iterator. And it is an iterator. What an iterator means is you can call the next function on it and it will give you the next value. But an iterator and an iterable are different things. You can iterate over an iterable, and the iterator is used to get the next value from a sequence or from generated values. So what we've got ourselves here is an iterator, not an iterable. We're going to learn in the next video how to create an iterable so that we can loop over it, or indeed do things like sum of mygen or whatever it is that you want to do, list of mygen. These things here need an iterable, not an iterator. So let's do that in the very next video. I'll see you there.